Across the world, we're in a revolution. Renewable energy sources are slowly and surely building themselves up. According to the Department of Energy, since 2008, solar power generation has multiplied 35 times in the United States. Here at the University of Maryland, we've generated 17.2 gigawatt hours just from solar power alone. Wind, too, is on a hot streak. The University of Michigan reports that there are more than 59,900 wind turbines installed in the United States today, totaling to a capacity of 107.4 gigawatts. Both of these technologies will be key in our fight against climate change and transition to renewable energy sources. However, they both have a very key weakness. Sometimes the sun doesn't shine and the wind doesn't blow. Unfortunately, humans use electricity 24 hours a day, 365 days a year, and need a source of energy that can provide a consistent output. More consistent sources, such as hydroelectric power and nuclear power, can fill in the gaps, but unfortunately aren't enough. To combat the coming climate crisis, we need to be able to rely on all types of renewable energy. What if there was a way we could save some energy from peak hours to use later when there's less energy input? Well, there is a way to save energy, one that you're all likely familiar with: batteries. But we don't just need a couple of AA's. No, we need much, much more than that. Some power grids have already begun to add battery systems. One of the most famous examples of this is the Hornsdale Power Reserve in Australia. It has a capacity of 150 megawatts. That's equivalent to around 38.4 million AA batteries. And it's not cheap either. The battery cost $90 million to build. This battery station currently serves the power grid of southern Australia, which uses 11,890 gigawatt hours of electricity per year. The University of Maryland uses around 202,400 megawatt hours per year. Now, there are an incredible number of variables to calculating a cost and required capacity of an electric power reserve station, but if we linearly extrapolate Australia's usage to cost numbers to the University of Maryland, we can estimate a cost of $1.6 million. Here's the thing, the technology for this mostly exists. The innovation required here would be one of policy. We need to convince the correct people that making this investment would be valuable for everyone. And it will be. Here's why. The construction of a facility such as this would provide a fantastic benefit to the UMD community. Not only will local energy providers be encouraged to build more renewable energy sources emboldened by this new backup system, they will also feel safer in decommissioning old, non-renewable sources. This would strengthen our power grid and put us ahead of the curve in terms of energy innovations. However, it could also help us set an example for the rest of the United States. Places such as Australia have already begun to build these power stations. Australia's first battery system worked so well that it began to expand and build more of them across the continent. Maryland and the UMD community could be the ones to catalyze this growth on this side of the world, starting a similar chain reaction. The price tag for a facility such as this is undoubtedly high, but the rewards it will reap for our community and the world as a whole are priceless. An investment in an electric power reserve station could go a long way towards making a cleaner, greener world for all of us. Thank you for watching.